Hi, welcome to Pre-Calculus. Topic today is using a trigonometric ratio to find an angle measure in a right triangle. So we are approaching the topic of solving a triangle. By solving a triangle, we mean finding missing sides or missing angles and such information given other information we have about the triangle. So this is the simplest type. I have written here the basic definitions in a right triangle. So this triangle is a right triangle. So these two are the legs, it's hypotenuse. One of the angles is in question. Typically, two of these sides are given. It could be any combination, and then we are looking for the angle. Let me remind you, sine of an angle is a ratio of its opposite divided by hypotenuse. So if I consider this one as my main angle, this would be the opposite of it. This is the adjacent of it. This is always the hypotenuse. Cosine is a ratio of adjacent to hypotenuse. Tangent is a ratio of opposite to adjacent. Well, we have learned 6 trig functions, and you might be wondering, why don't we treat these ones in the picture? I've written the relationships. You would notice that when you try to use your calculator, these are not represented on the calculator. Calculator has very small area for its buttons, and so they have to economize, and certain things get to be pushed to the side. So a typical calculator doesn't have these 3 trig functions, and the prominence is given to these 3. So that is something to keep in mind. Now, here's a typical question. Here the angle is referred to as x. In the picture here I did theta. We look at the picture, we see these two are given. With respect to this angle, this will be its opposite, and this is always the hypotenuse. So we write the relationship between these 3 quantities. The relationship would be that the sine of x, in this case, sine of x, how did I choose sine? Why not cosine or tangent? Because this plays the role of the opposite, and that is the hypotenuse. So sine of x is 3 over 5. Now I go ahead and find x from this relationship. That would be arc sine of 3/5. So in the page that you are operating in, there's a calculator, and so calculator, when you open it, is in degrees. You want to make sure that's what you want. So for example, this problem says to the nearest tenth of a degree. If it's at in radians, then make sure that you click that to convert it into radians. But here is, we are asking this. Let me actually make sure that that is what we wanted to do. This one, it looks like they are all in degrees. So let's go back here. So all we do is choose one of the 3 functions according to what we have in our picture. So in our picture was sine inverse. Sine inverse, this calculator is extra nice, opens the parentheses for you as well. And in the problem that we had, it was 3/5. So we come here, and here's 3/5 equal to 36.86. To the nearest tenth of a degree, it's going to be 36.9. So my answer would be 36.9 degrees, and that would be the answer. So 36.9 degrees Well, right now it just says a tenth of a degree. Once you take your science class or particularly physics class, they do make quite a bit of fuss about, well, what should be number of digits we represent in our answer. So that has to do with the accuracy with which you measured your other information from in the problem. That becomes a rather extensive discussion, and in some sense, the issue goes all the way to calculus 3, and it's beyond the scope of this lectures right now. We just follow whatever is given to us here. So the issue of precision of the numbers is a significant issue. We are going to postpone that. In this case, we have this angle x we want to find. We look at it, so well, adjacent is given, and the opposite is also given. So what is the relationship that connects these three? Adjacent and so let's write it here. So for sine, we have the opposite and the hypotenuse of the angle available. For cosine, we have the adjacent and the hypotenuse available. For tangent, we have the opposite and adjacent available. So in each picture, we have to decide, well, what is it that's available? For the angle x, I have the adjacent and opposite. That means I have relationship for tangent. So tangent of x is 16 over 11. So x is going to be arctangent of 1611. Now, the name of the functions that we are going to be using, sometimes they're written as arcsine, sometimes they are written as a sine, sometimes it's written as sine inverse. So all three are in use depending on the style of the book or the calculator that you have. Your own personal calculator might separate the arc portion from the sine portion. That is, you could see a button that is labeled either arc or F inverse or something. A combination of that with the sine button is going to have the effect that we have in mind. Same way for cosine and tangent. So you have several styles: arc cosine, a cosine, or cosine inverse. These are all in use. Same way, arc tangent, a tangent, or tangent inverse. These are all styles in use. So when you are using in the calculator that's provided to you in LX, it's the notation of function followed by inverse on top of it. So again, based on makes and model of the calculator you have, these functions could be represented in different style. Just check the manual of your calculator and see. So in the calculator you use here is written in this style: tangent inverse of 1611. Let me go ahead also in the calculator that you have up here. This is sine inverse of 3/5. That's how it is typed. In this case, I have the angle x, and I have this and that one. With respect to angle x, this is going to be counted as adjacent. This is always hypotenuse. So the relationship I'm after is that the cosine of x is 9/12. You can simplify, you can leave it alone. So x is going to be a cosine inverse of 9/12. So the idea is very straightforward. The angles and the sides of a triangle have a relationship with each other. That is essentially how we defined the trig functions at the beginning. And now we are using the inverse trig function and the dimensions that are given to find the angles themselves. What are we going to use this thing for? Our grand plan is to solve a triangle. So where are we headed with all of this? We might have an arbitrary triangle, not necessarily right or anything. So it has three vertex. There are vertices here. There are angles, typically shown alpha, beta, gamma. There are three sides, typically referred to as A, B, and this is little c. And of these angles and these sides, some of them will be given, and we are searching for the other ones. That's going to bring us to certain famous laws, law of cosine, law of sine, and a whole range of formulas related to them. There are even law of tangents, but not necessarily mentioned in all text. So what we are heading toward is solving a triangle. It's a general triangle, and the objective is to find the missing information from this list of 6 based on what they have given to us. Okay, so that's what's going to come up next. Until then, good luck and God bless.